All right, today we're going to look at a different strategy for solving systems of linear equations. Yesterday, we learned how to graph equations and check our solutions. So here's what I'd like for you to do. Go ahead and do your warm-ups, 1, 2, and 3. Hit pause. When you're done, come back and check your work. All right, let's see how you did. When you graphed your equations, remember each equation set equal to y. So the last one here, you had to rewrite in slope-intercept form. When you did that, your first equation, you ended up with points crossing at, or lines crossing at -1, 3. For 2 was 2, 1, and for 3 was 4, -8. You can go ahead and hit pause if you'd like to take a closer look. All right, so yesterday we talked about graphing. Now, this unit is all about solving systems of equations, and today we're going to do it by substitution. Now, substitution means replacing one thing with another. So the first thing we're going to do is solve one of the equations for one of the variables. What does that mean? That means solve for x or solve for y. So for example, here, when I rewrote 6x plus 2y equals 8, it turned into y equals -3x plus 4. Those are the exact same equations. So in order to solve this for eliminate or for substitution, we're going to rewrite it so it looks like this. The next thing we're going to do is we're going to substitute the expression, so our newly written expression, from step 1 into the other equation and solve. Next, we're going to take that answer, so we'll have an x equals 5 or a y equals 2. Then we'll substitute or replace the value, because we now have a y equals 7, from step 2 back into the original, now that's the key there, equation. So what does that all look like? Well, what's nice here is this step 1 has already been done for us. So when I look, I've already got a variable by itself. So this is going to be my equation 1. Okay. This here is my equation 2. So step 1 is done for us already. How awesome is that? Now, what I'm going to do, this is telling me that y is equal to 2x minus 4. So I'm going to replace this with that y. So we have 7x minus 2, which is that first part. Now I'm going to replace this y with 2x minus 4. Why? Because it told me that this y is equal to that. So remember, they have the same value. That's what that equal sign means. Okay. Now that I have a new equation, I'm going to solve for x. First, I'm going to distribute here. So I have 7x. Now think about this as a negative again. -2 times 2x is -4x. -2 times -4 is +8. Next, I'm going to combine my like terms. So I have 3x plus 8 equals 5. I'm going to solve for solve for x by isolating and balance. So I end up with x equals -3. Now that I have my value for x, I can replace it in either one of these equations. So one of the things I want to make sure you understand with step 2 is you can't replace this in here and have 2x minus 4 equals 2x minus 4. You have to replace 1 into the second equation. You can't use the same equation twice. So now that I have x equals -3, I can put it in either one. But since this one's already solved for y, I have less work. I can need to do here. So I have y equals 2 times negative 3 minus 4. So y equals, whoops, this is negative 1. Oh my gosh, what was I thinking? So I've got negative 1. I'm like, something's not right here. So 2 times negative 1 is negative 2 minus 4. So y equals negative 6. So glad I caught my mistake here. So my solution, remember, the solution is always a coordinate. So my solution here is negative 1, negative 6. So this right here is your answer. Okay? Although that kind of wiped out my answer there. So negative 1, negative 6. All right, what I'd like for you to do is try these next 3 on your own. Go ahead, hit pause. When you're done, come back and check your work. All right, how'd you do? Well, if I take a look at the first one, I replaced 2x plus 3 with y. So we had 2x plus 3 equals 5x. Solved and ended up with 1, 5. For 2, I replaced 1/2 x minus 5 with this y right here. So I ended up with 4x plus 2 times the quantity 1/2 x minus 5 equals 0. So I'm just replacing, I'm substituting here. Ended up with a final answer of 2, negative 4. Now here, I already had x solved, so I replaced this x with 5y plus 3. So I have 2 times the quantity 5y plus 3 plus 4 minus negative 1, and I end up with 1/2 negative half. Now, you can always hit pause to double check your work if you made any mistakes. All right, so when am I ever going to use this again? Well, you buy a total of 50 turkey burgers and veggie burgers for $90. You pay $2 for each turkey burger and $1.50 for each veggie burger. Write and solve a system of linear equations to find the number x of turkey burgers and y veggie burgers. So our variables are already defined here, but let's write that out. So x equals number of turkey burgers and y equals number of veggie burgers. Okay, so what do I know? I buy a total of 50. So this is my total number. And I'm really not sure how many, that means I bought some. So my x here is the number of turkey burgers. And my y is the number of veggie burgers. So x plus y is going to equal 50 because there's my total of 50. Now, my cost here was 90. And what did I pay? So $2 per turkey. And then $1.50 times veggie. So this was the number, oh, that's the cost. So this is the cost of the turkey burger. This is the cost of veggie burger. And then number of turkey burgers, which I have no idea, and number of veggie burgers. So I know I bought $50, or I know I bought 50 total, and I know I spent 90 total. So what are my equations? So I've got my system here, x plus y equals 50, and then 2x plus 1 and 5/10 y equals 90. So unfortunately, this time I don't have anything x equals or y equals set equal to x or equal to y. So what I could do is pick any one of these and solve. So I'm just going to stick with solve for y because that's just kind of, I guess, what I'm so used to. So I have x plus y equals 50 minus x. So I have y equals negative x plus 50. So now here are my two equations. I want to be very careful not to replace this into this because I'm going to get a solution that's not going to be very helpful. So I want to look at those two different equations. So my step one, I now have y equals negative x plus 50 and 2x plus 1 and 5/10 y equals 90. So now my step two is I'm going to replace the variables. So here I'm going to replace my y with negative x plus 50. So I have 2x plus 1 and 5/10, but instead of y, I'm going to use negative x plus 50 equals 90. So I have 2x. I'm going to distribute. So 1 and 5/10 times negative x is negative 1 and 5/10 x. 1 and 5/10 times 50 gives me 75. Now I'm going to combine my like terms. So I have 5/10 x plus 75 equals 90. Subtract 75 from both sides. So I have 5/10 x equals 15. Divide by 5/10, so x equals 30. So now I've got my first solution here. I've got x is 30. Now I'm going to go back to the original here. So I have x plus y equals 50. X is 30. 30 plus y equals 50. Subtract 30 from both sides, so y equals 20. Now, let's use a complete sentence here to make sure I actually answered the question. Let's see. You buy, all right, 30x. So x was turkey burgers. You buy 30 turkey burgers, and y is veggie burgers, and 20 veggie burgers. Oh, don't forget your period. All right. Have a great day, everybody. Take care.